Okay, let's graph this rational function, d of x. So as we're preparing to graph it, it's in our best interest to get this in as factored form as possible so we can easily identify any zeros in our numerator or denominator. So the first quadratic in my numerator, I can see an x in common between x squared and minus 3x. So I pull that out and I'm left with an x minus 3. And the second quadratic in my numerator, I believe is going to factor nicely if we take minus 6 and positive 4. That's how we can recover that minus 2x and the minus 24. And my denominator has a 10x in common. And if I remove that from the first term, I'm left with a single x. And then if I remove it from the second term, I'm left with just a 1 there. So immediately I can identify any removable or non-removable discontinuities. So this x right here, it's a factor of my numerator and denominator. So that is going to be a removable discontinuity. I'm left with x minus 3, x minus 6, and x plus 4 divided by 10 times x minus 1. And I see that I cannot remove that x minus 1 factor, so I do indeed have a vertical asymptote at x is equal to 1. All right, and I'm going to put a little 1 right there in parentheses to denote that this factor occurs once. It has multiplicity 1, and we know that the evenness or oddness of the multiplicities is going to affect the shape of the graph. So what else do I know from looking at this factored form of the function? I know from these factors that my function is going to experience zeros at 3, at 6. So I did not draw my graph large enough. Let's move it over a little bit. So I've got another 0 at 6 and a 0 at minus 4. Okay, now let's talk about end behavior. So is this function going to experience polynomial-like behavior, a horizontal asymptote, or what? So I can look in my simplified version here after I've removed any removable discontinuities, or I can go back up to the original function and they'll both give me the same answer. So here, if I look at the original form of the function, I have a degree, what? 2x's right there times another 2x's right there. So if I performed this multiplication in my numerator, I'd end up with a quartic function, x to the 4th something. So I've got a degree 4 being divided by an x squared right there, so a degree 2. So that would give me a degree 2 polynomial. So let me get rid of all these notes. So I'm going to expect in behavior like a quadratic because the leading coefficient in front of this x to the 4th is going to be a 1. And the leading coefficient in front of the x squared term down here is a 10. So this quadratic is going to have a leading coefficient of 1/10. So it is going to be concave up or facing upward. Okay, so my end behavior, which I'll denote in green, is going to do something like 1/10 x squared. All right, something to that effect. Now I think we're ready to fill in the gaps. Let's start here at 3. And as I move in the leftward direction, I do not know if I need to go down like this or up like this. So let's figure out if I'm positive right there or negative. Let's take a test value at 2. What is this function d going to return at 2? So I can use my simplified version here. If I plug in a 2 into this, I end up with a -1 in the first factor, a -4 in the next, a 6 in the next, and divided by just a 10. So in total, what do I have on top? I've got 4 times 6, which is going to be a 24 over a 10, 2.4. So it is a positive number. So I'm going to go up like this. Now, as I approach this vertical asymptote, I can never actually reach it. So I'm going to be forced to move upwards infinitely, but I'll get infinitely close to it. Now, think about this 0 here at 3. It is a consequence of this factor in the numerator. And that factor appears once an odd number of times. So I'm going to pass through that root. Now, as I'm approaching the root at 6, I also note that that factor, x minus 6, appears once an odd number of times. So my function is going to pass through that root as well. And it is going to approach this green quadratic behavior that I know I'm supposed to approach. Now let's think about what's going on the other side of this vertical asymptote. So if my function, as I'm traveling along here, is going up towards positive infinity on the right-hand side of the asymptote, and I know that this asymptote has odd multiplicity because it is a consequence of this x minus 1 factor, which occurs one time, then that odd multiplicity is going to make my function do opposite things. So if I approach positive infinity on the right-hand side, I'm going to approach minus infinity on the left-hand side. So as I move towards my y-axis, I could ask myself, hey, where do I cross my y-axis? So let's evaluate d at 0 and see what we get. Oh, wait a minute. That was one of my removable discontinuities, right? X could not be 0. So as I move forward, I have an open circle at 0. Oops. Let's see what we get close to. If I evaluate this function at 0.001, I get, not exactly, but I get something that's about minus 7.205. So that means I'm going to probably cross somewhere at minus 7. But I'll have an open circle there, a removable discontinuity. And as I move forward, I pass through that minus 4 because the factor x plus 4 occurred with odd multiplicity. It only occurred once. And I catch up with my green end behavior that I know I'm supposed to get. So this would be a rough idea of what the sketch of this rational function is going to look like. Okay, hope you found this helpful.